Hi everyone, so my name is Sanskruti Bhamne. I am doing my BET third year in stream of Electronics and Telecommunication from VPKBIT Baramati. I have done my online internship on the embedded systems provided by the Emertex Information Technology. So in this project, I have learned about the introduction of embedded and its components and software used in the project, and especially PIC16F877A microcontroller. We can implement this project by using the embedded C and peripheral components such as a digital keypad, CLCD and buzzer, etc. And finally, I will show you the project demonstration and sample output. So let's going into the brief introduction about this project. So basically, the purpose of this project is to produce a real-world washing operation in the virtual environment by simulation using the picsimlab. So in this project, we have built a simple washing machine prototype using the PIC16F877A microcontroller. This project explains about the washing machine. So we know washing machines are used in our daily purpose in our homes. So whenever we are washing clothes by hand, so it will take more time and human energy. So for that purpose, we are implementing an automatic washing machines. Nowadays, customer wants to have a fully automated washing machines. Embedded system. Embedded system is basically a microprocessor which is small in size, and it can work independently as well with the large system. For example, calculators, washing machines, drones are the examples of embedded systems. So embedded systems are classified into two types, that is based on the functionalities and performance, and another is ability of microcontroller. So first is the real-time embedded system. Real-time embedded system means that it has specific time to perform a task. For example, the real-time example of these are healthcare sectors, medicals and defense sectors. These real-time embedded systems are divided into two types, soft and hard. Soft means it can have delay in performing tasks, and if the deadline of this task is passed, the system doesn't give result in a defined time, then the result or output is accepted. While in the hardware, the system follows a strict deadline. For example of the hard real-time embedded systems are traffic control systems and military uses in the defense sector. Another is the stand-alone embedded system, which means that it can work by themselves and they are not dependent on any other host. It takes the input in digital or analog form and provides the output. For example, MP3 player and calculator. Network embedded systems are connected to network which may be wired or wireless to provide output to the attached device. For example, ATM machines and card swipes are the example of a network embedded systems. In mobile embedded systems, they are small and easy to use and requires less resources. For example, our phone, then digital cameras are the real-time examples of the mobile embedded systems. Another is that based on the ability of a microcontroller. Small scale embedded system. They are designed using 8-bit or 16-bit microcontroller. They can be powered by using just a battery. Then another is the medium embedded systems. Medium embedded systems are designed using 16 or 32 microcontroller. These medium scale embedded systems are faster than the small scale embedded systems. Last is the sophisticated embedded systems, which are designed using the 32 or 64-bit microcontroller. These are developed to perform a large scale complex functions. So now we are going to see the components of the embedded system. So embedded system contains a processor, memory, sensors, actuators and user input-output interfaces. So first we will see the processor. Processor is responsible for executing instruction and controlling the operation of an entire system, while the memory requires various types of memories to store program instructions, data, and temporary variables. These include RAM and ROM. Input-output interfaces enables the connection between the external environment and embedded systems. The examples of these input-output interfaces can be or are UART, SPI, and I2C USB ports. Then the sensors and actuators. Sensors are used to detect physical quantities such as temperature, pressure, or light, while the actuators, on the other hand, are used to control physical processes or devices based on the input from the sensors. Examples include temperature sensors, motors and relays, and solenoids. Embedded system can also include RTC, that is the real-time clock, for tracking of time even when the system is powered off. So now we are going to see the software used for our project. First is MPLab, XCAT compiler, and the picsimlab. MPLab, which is a free software used for the development of embedded application on PIC and DSPIC microcontroller, and it is developed by the microchip technology, while the XCAT compiler is powerful and converts the ISO code into the high-level language. picsimlab is a real emulator of a development boards with the MPLab. Why PIC16F77A microcontroller? Now we are going to see the specifications of this microcontroller, as we have used this microcontroller for our project. So it has 40 pins, it has 5 ports, supports serial communications, and its operating frequency is 20 MHz. And this, because of this, it has a good balance between the complexity and simplicity. Then because of the flash program memory, which is of 8 KB, is reprogrammable and allows for the easy updates and modification to the firmware. Embedded system, Embedded C. Embedded C is used to program a wide range of microcontroller and microprocessor, because it is a processor independent, and C language is not, that means it is not specific to any microprocessor or microcontroller. It can work on various hardware systems. It can work on a very hardware configuration. C doesn't really require the same set of a hardware to run a program. And then another advantage of embedded C is that it provides us with the portability. That means when an application can be moved from or moved to the other operating systems. That is, code developed in C is more portable, and user can compile it on code on other platform with the least modifications. One of the most important advantage, it provides us with the memory management. That is, it provides direct memory control without sacrificing the benefits of high-level language. It provides us with the better performance than any other language, because since the C code gets compiled into raw binary executable, which can be directly loaded into memory and executed. So now we are going to see some components or peripherals of the components used in a project. First is the CLCD, that is a character liquid crystal display. So we have used 16:4 CLCD in project. That means the 16s are the number of columns and 4 are the number of rows. So total number of characters in the our LCD can be 64. It cannot be more than that. So LCD is basically a type of flat panel display technology used in electronic devices. That is, for example, we use it in the televisions, computers, monitors, smartphones, and calculators. And it operates on the principle of color emission. Another is the tactile switch. The tactile switch has a digital keypad. So basically, as we know, the tactile switch is one of the widely used switch that completes an electrical circuit. Typically, when the pressure is applied to the device by the user, which then gives user a click or a bump in a response, indicating that a current is flowing. But when we release this button or a switch, the current stops flowing through it. So we will see the interrupts. Interrupts are basically the signals that tells a microcontroller to stop what it is doing and execute the specific function, which is called as the interrupt service routine, that is ISR. These interrupt sources are external as well as internal, and the classification of the interrupts are the maskable and non-maskable. PIC microcontroller, PIC 16F877A microcontroller have 3 timers, that is 0, 1 and 2. But in our project we have used the timer 2 for providing us with the delay procedure to implement some delays in the program, that was counting up to a specific value before the program could continue. The timer 2 has a 2 count registers, TMR2 and PR2. The size of each register is 8 bit, in which we can write numbers from 0 to 255. The TMR register and PR2 are both readable and writable, and we have set the PR2 equal to 250 in our project. So these are some sample outputs of our project. Now we will move towards the demo of the project. So first we will build the project. Yes. So this is the picsimlab we have used for having a virtual environment. So first we have to select the board, that is the PIC Genius board, and the microcontroller is the PIC 877A microcontroller. As I have already uploaded this file, okay, I will upload it again. So this is the hex file that we have to upload after building it. So as you can see, this picsimlab, and this is the microcontroller. This is the buzzer, fan, and switch 1, 2, 3, 4, 5, 6. Okay, so this is the LCD, which is 16:4. We have set from here, and we have set the clock frequency, that is 20, and we will reset the okay, I will run it again. Okay, set the PIC Genius. Okay, now we will load the file. Okay, then for starting power on in the washing machine, we have to click the switch 5 only once. So for traversing through the options of our washing programs, we have to click the switch 4, heavy, delicate, whites. If you want, let us go with the whites. If you want to select this option, we have to long press the option switch 4. Okay, now there it will show that water level requirements, that is auto, medium, low. For traversing, again we have to choose this switch 4. Okay, let us go with the low. Whites. White is the basically type of a cloth, and here we are choosing low water level for it. For choosing, we have to again long press switch 4. Okay, So now for starting the washing of the clothes, we have to press switch 5 for the start and switch 6 for the stop. This is 5 and this is 6. Okay. It will show the time required for the washing clothes. So now we can see that the fan is on and we can see the temperature, that is 27.50 degrees Celsius. Timer is on. If you want to pause this timer in between, then we can press the 6th switch once. Okay, for starting it again, we have to press the 5th switch. We'll see some code of this. See, you can see from here that we have set the value of 250, PR equal to 250 registers. Then TMR2 on is set to the 0 because for initially we want the timer to be off. This is the code for the first slide they had, for the first slide that we have seen on the LCD, which is for the power on screen, that we have designed it that so that the 5, when we press the switch 5, then it will start the power. Then this is the code for displaying the type of a cloth that we want to choose, and this is the code for the water level display that shows the amount requirement of the water that we want to pour into it. That is the, for example, it was auto, max, high, and we have set the time for the particular type of a cloth as well as a water level index. Depending on that, we have used the switch cases for each type of the cloth and water level. And last one is the run program. After 3 seconds it will show that remove the cloth. See, the buzzer goes on and fan stops. It will again return to the first page. That is the first program, that is of a washing program. And then thank you for providing me this opportunity. So at the last of this conclusion, this simulation let us study offers the insights into washing machine operations and control system designs.